All right, babies, here we go with example number 3. So what are we going to do first? Factor, Miss Griggs. Very good. That's what we're going to do. So we're going to factor this. It's a magical time. Very good. Now the very next thing we do, we're going to take care of our domain. So we've got, oh, that was horrible. The writing. X cannot be 1. X is a set of real numbers. Okay, so once we get through that, now we start with all of this information. So the vertical asymptote, X equals 1. All right, the horizontal asymptote, remember we look at the degree. Well, nothing was able to factor here, so we really don't need, or I mean not factor, nothing was able to reduce, so we really don't need that anymore. So I'm going to look at this. The degree is 2, the degree here is 1. That means that there is not a horizontal asymptote. That means there's probably a slant asymptote. So remember what the rule is. If my numerator has 1 degree higher than my denominator degree, then I will have a slant asymptote, not a horizontal asymptote. So let's find that slant asymptote. I am going to use long division to do this. X times what gives me x squared? That would be x, and I have to distribute. So x squared minus x, change the signs. This becomes negative, this becomes positive. And now I've got 2x minus 6. X times what gives me 2x? Well, that would be a 2. So I've got 2 times x, and then 2 times negative 1. Change the signs. Don't really need anything after that. That's all I care about. I've got y equals x plus 2. That's my slant asymptote. All right, the x-intercepts are next. I'm going to set my numerator equal to 0 and solve. So I've got x squared plus x minus 6 equals 0. I know this factored into x plus 3, x minus 2. So I've got 2 solutions for x. So I've got 2 x-intercepts. All right, and now the y-intercepts, remember that's when all of your x's are 0. So that gives me positive 6 over 1. So my y-intercept is 0 and positive 6. I was not able to reduce anything up here, so there are no holes. And now it's time to graph. So I'm going to graph my vertical asymptote. X equals 1. There is no horizontal asymptote. When I graph my slant asymptote, you have to notice that this is in slope-intercept form. So the intercept goes through positive 2. The slope is of 1. So it's going to look just like that. Hopefully I can draw that nice and straight. We'll see. Oh, not bad. I've done worse. Okay, now it's time for our x-intercepts. We've got 2 of them. We've got one at negative 3, 0, and we've got one at 2, 0, just like that. Excellent. So our y-intercept is 0, 6. That's going to go up here. That tells you that your graph, remember, it's going to be hugging the asymptotes, so it's going to look something like that. Okay, so that is your graph. Oh, I didn't do a good job with this, did I? Hold on just a second. My line for my asymptote, oh man, that's not what I wanted it to do. Poopy. Never mind. What I meant to do was make it a dotted line. You can't take me anywhere. Okay, that's what it should look like. I'm sorry, kids. So broken. All right, so that is what your graph should look like, and now we're going to talk about all of the other stuff. So the range. Well, the range, if you'll notice, here's my graph. Okay, so it goes down to negative infinity, so that's for sure going to get covered. But then it goes all the way up here, and it's going to be all the way up there in the positive direction and in the positive direction here. So technically it's going to cover all of the range. We don't have any holes or skipped y values for this particular problem. So that's how we know it's the range, or that's how we know the range is negative infinity to positive infinity. Okay, so graph behavior. We have end behavior and we have asymptotic behavior. So we are first going to look at the end behavior. This can get a little confusing because we are used to having end behavior at horizontal asymptotes, and that's okay. Now, instead of using the horizontal asymptote, we're going to use the slant asymptote here. So this is where the end behavior is, right there and right there. All right, so as x approaches here negative infinity, y is going to approach negative infinity. And up here, as x approaches positive infinity, y is approaching positive infinity as well. Pretty exciting, isn't it, kids? I know, you're welcome. All right, so now we're going to talk about I've got to use a different color so you can see it better. All right, now we're going to talk about the asymptotic behavior, which occurs right here and right here. All right, so in this one, x is approaching my asymptote at y equals 1. So x is approaching 1 from the negative direction here, and y is approaching positive infinity. And down here, my graph is approaching 1 from the positive direction, and y is approaching negative infinity, just like that. Awesome. All right, now we're going to talk about increasing and decreasing. Well, from left to right on this side, it's increasing, right? So it's increasing from negative infinity and it's going to increase to negative infinity, from negative infinity to 1. And then over here, see, it jumps over the vertical asymptote and it's increasing again. So it's increasing from 1 to positive infinity. It is not decreasing anywhere. Score. Enjoy graphing, kids.